Hello friends, let's start today's session with quadratic equations. Okay, so we are solving uh, quadratic equations today. So I'll tell you there are two methods in quadratic equation. Okay, for solving. Okay, both I'll tell you. First is called factorization. Okay, and second one is called Sridharacharya method. Sridharacharya method. So basically, Sridharacharya method is a formula method, and factorization is midterm factorization, which I'm going to show you. Okay, so first let's understand what is this quadratic equation. So the quadratic equation is having this general equation like this: x square plus bx plus c is equal to 0, where a and b and c are coefficient of x square, x and c is a constant term. Okay, so what is the condition here? Condition is that a should not be equal to 0. If a will become 0, this will land up to bx plus c, then it will be not a quadratic equation. Okay, so before solving a sum, okay, let's write first one equation. Okay, suppose we are adding x square plus 10x plus 21 is equal to 0. Okay, so you can see if you compare this equation with quadratic one, so you will find a equals to 1, b is equal to 10, and c is equal to 21, right? So now first I'll solve this by this factorization method. So in the factorization method, what we have to do, we have to multiply this x square with 21. Okay, which is 21 x square. Then we have to find the factor of 21. So we will factorize 21. So let 3, and then it is 7, and then 7, and then 1. So you see that we have 3 and 7 are the factors. So we have to arrange the middle term, okay, which is 10x in this 3 and 7. So obviously if you multiply 3 into 7, you'll get 21, and if you add 3 plus 7, you'll get 10. So this particular strategy will make, and I'll write x square plus 3x plus 7x plus 21 is equal to 0. Okay, because 3x plus 7x is 10x, and 3x into 7x is 21x square. Then I'll take x common here, so it will become x into x plus 3 plus 7 into x plus 3 is equal to 0. Then x plus 7, and then x plus 3 is equal to 0. So either x plus 7 is equal to 0, then you'll get x is equal to minus 7, and or x plus 3 is equal to 0, then you'll get x is equal to minus 3. So it means that you have two answers, okay, for quadratic equations always. Okay, so those answers are called roots. Actually here they are called roots, and they are termed as alpha and beta. One root is called alpha, another one is called beta. Okay, so I'll talk much on this. Okay, so I'll talk much on this when I'll tell you this Sridharacharya method. Then I'll tell you more properties of this alpha and beta. Okay, so this is the factorization method. Okay, now let's do uh, this Sridharacharya method. Okay, I'm just rubbing this. Okay, so we are doing the same sum. Okay, to see whether, okay, obviously the answer will be going to match. Okay, we can do another sum also. Okay, let's say that. So I'm just for a while I'm just taking this sum only. And so this Sridharacharya method is having one formula: x equals to minus b plus minus uh, root of b square minus 4ac divided by 2a. Okay, so it will be x equals to, in this case we have a equals to 1, b is equal to 10, and c is equal to 21, right? So we'll put all these values in this equation, so we'll get minus 10 plus minus b square, which is 100, minus 4 ac, means is 1 into 21 divided by 2 into 1, which is 2. So minus 10 plus minus 100 minus 100 minus 84 divided by 2. So we'll get minus 10 plus minus 16 root of 16, right, by 2. So minus 10 plus minus 4 by 2. Root 16 is 4. So if you take plus sign, then it will be minus 10 plus 4 by 2. If you take minus sign, so minus 10 minus 4 by 2. Here I'm talking about. So you must be curious why the plus minus sign is there, because you see plus minus sign is there before square root sign, right? This is square root sign. So as we know that square root of any number, like suppose you're finding the square root of 25, which is plus minus 5. Square root of 169 is plus minus 13. Okay, so plus minus is by default. Okay, it will come. So that's why this plus minus is already there. So minus 10 plus 4 is minus 6 by 2, minus 3, and minus 14 by 2, this one. So which is minus 7. So we have the same answer, you see, right? Minus 3 and minus 7, which we get in the previous method also, right? So this is called Sridharacharya method, and this is very much handy. Okay, what I mean, like if you are not able to factorize, sometimes happens like you're not able to factorize only, then it will be little difficult. Little difficult means you cannot do only by factorization actually. Then anyhow you have to go for the Sridharacharya. Okay, this one. So I'm just showing you one sum where you will be not able to factorize. You have to go for Sridharacharya only. There is no way. Okay, let's see. And then I'll tell you the properties of the roots. So here the solutions which we are getting x. So as you see that there are two values coming, right? They are called roots, alpha and beta, and they are having relations of this alpha beta with the a, b, and c. I'll tell you that also. Along with that, I'll tell you the term called discriminant in this, and based on the discriminant, I'll tell you what kind of uh, sol what kind of solutions you can get. Okay, so let's see. Suppose we are getting one equation like this: x square plus 10x plus 7 is equal to 0. You see, in this case, if you try to factorize, like you're getting 7x square, 7, if you break maximum, you'll get 7 and 1. So 7 and 1, if you do 7 minus 1, it will give you 6. If you do 7 plus 1, it will give you 8. But it is not going to give you 10 anyway, right? It means that you cannot factorize this actually. Okay, it cannot be factorized. So as it cannot be factorized, so obviously we have to go for the Sridharacharya, then this one, the second method. So we can do this by Sridharacharya very easily. A is equal to 1, b is equal to 10, c is equal to 7. We'll put these values in this equation: minus b plus minus b square minus 4ac by 2a. Okay, so then minus b equals to 10 plus minus 100, 10 square is 100, minus 4, a is 1, c is 7, divided by 2 into a, means 2 into 1. Okay, so minus 10 plus minus 100 minus 28 divided by 2, minus 10 plus minus 100 minus 28 is 72 divided by 2, minus 10 plus minus 72 is 6 root 2 divided by 2. So if you take the plus sign, so minus 10 plus 6 root 2 by 2, which will give you minus 5 plus 3 root 2, right? And if you take minus, so this is one of the solution. The second solution is I'm writing here in the right hand side. So we have minus 10 minus 6 root 2 divided by 2. If you take 2 common, so minus 5 minus 3 root 2. This is the second answer, right? So the answer is minus 5 plus 3 root 2 and minus 5 minus 3 root 2. These are the two answers. Root 2 we know, right? Root 2 is equal to 1.414. We can find that even, and we can get the exact answer in the decimal. Okay, but that's not required actually. They're not expecting the answer in that much detail. Okay, this answer is also okay. Okay, right? So you can see how efficient and how easy the Sridharacharya method is, right? You know the A, you know the B, and you know the C, and you just put the values in the equation and you're going to get the result. Okay. So now I'm telling you some aspects of the roots alpha beta. Okay. Based on the uh, term D. Okay. The D is called discriminant. Okay. And what exactly the meaning of D is there, I'm just telling you. Okay. And how it decides that your roots will be what? Either it will be single root, or it will be double root, or your roots is real, or your roots is imaginary. It will tell you whole story about the roots. Okay. Or the solutions. Let's see. So D is a discriminant which is having value b square minus 4ac. So this b square minus 4ac having it can be greater than 0. If it is greater than 0, then roots are real. Roots are real. Roots are real. Okay. And distinct. Real and distinct. Distinct means different. B square minus 4ac, if less than 0, then roots are imaginary. Roots are imaginary. Okay. Means not real. Imaginary means not real. If b square minus 4ac is equal to 0, then roots are same. Okay. Roots are same or single, you can write single root because they are same. Okay. So these three behavior will tell you about the roots. Okay. So let's take a example. Suppose we are taking x square plus x plus 1 is equal to 0, and we are going to find the value of d. Okay. So if you find the d, you see 1 square minus 4 ac means, if you, because your a is 1, b is equal to 1, and c is equal to 1. So if you find d, you'll get 1 minus 4, which is minus 3. So d is equal to minus 3 means it goes here, right, in the second one, where the roots are imaginary. So obviously you're not going to get the real roots. Okay. Imaginary means you will get an imaginary number kind of concept, where z is equal to uh, this is a complex number where we write z as 3 plus 3i. So this I, the answer will be coming in I actually. This is called iota. I is done for iota. Okay. It's a complex number, algebra. Okay. So now I'm showing you one of the example where the b square minus 4ac will come 0. Okay, let's see. So just taking example where you will see that b square minus 4ac is coming 0. Okay. So it is this x square minus 9x plus, not 9x, it is here minus 6x plus 9 is equal to 0. Okay. If we find d here, so in this case your a and b and c is going to change. Your a is 1, b is minus 6, and c is 9. Right, we'll put this here in the formula of b square minus 4ac. So we'll get minus 6 square minus 4, 1 into c. So we'll get 36 minus 36. You see, 0 is coming. 0 is coming means what? The roots are single root. And here in this case, the root will be like this, you see. I can even factorize 6x. I will write minus 3x plus 9 is equal to 0. So x into x minus 3 minus 3 into x minus 3 is equal to 0. So we'll get x minus 3 square is equal to 0 means x minus 3 is equal to 0. So x is equal to 3. So x is equal to 3 is your solution. Okay. Single solution. Okay. X is equal to 3 is coming twice. Okay. That's why the roots are single. Okay. This already we have seen, right? The first example, when we did the sum where we got the minus 3 and minus 7 the answer, right? Remember? Where you see that d was greater than 0, right? That's why we got two distinct solutions. Okay. Now, apart from this concept, there is another concept in this quadratic equation which should not be missed. I'm just writing that. So that concept is actually relationship of coefficient of coefficient of x square x and the constant term with the roots. Okay, which you can write in this way: alpha plus beta means the addition of the roots will be equal to minus b by a, and alpha into beta is equal to c by a. Okay, these are the two roots. Okay, which can frame the equation. When you are framing the, when you have the solution and you are framing the quadratic equation, then you can use this particular uh, formula. Okay. Apart from this, there are a lot of behaviors which we can see. So basically, if I tell you the graphical interpretation of this quadratic equation, so it's a parabolic curve. Okay. uh, it can be like this, even it can be even in this way, right? It depends on the value of a sign of a. Now now as we, so basically, uh, as we have seen, let's take an example where we had the answer -3 and -7, right? So -3 -7 means this parabolic curve is is cutting the x-axis here. -3 -7 means like this. This is -3, this point is -3, and this point is -7. This kind of curve is there. Okay. So the roots means the curve is cutting at it at x-axis. Where exactly? That point of x-axis is the solution. Okay. This is the graphical interpretation of the curve. Okay. So yeah, so means by the by the methods or by the concepts whatever we have done in this lesson, I think we can do lot of advanced sums in quadratic equation, which is asked generally in SAT and CAT exam. So I think you can go and do the sums. If you face any problem, please let me know. Please shoot me the mail. I'll be helping you throughout. Okay, in your preparation. And just after this lesson, I'm going to teach you a new lesson, which is uh, cubic polynomial. Okay, where I'm going to show you how the cubic polynomial will give you three different solutions, or the solutions can be same also. It depends on the situation, right? Now, okay then, bye, take care. See you in the next class. Bye bye, take care.